Okay.
They are all involving, sir, actually.
Okay.
Eager to learn many technologies.
Hope so.
Because they had to go long career, sir. I saw your profile very well, sir. Achieved a lot of laurels.
Thank you, sir. Thank you.
Always the engineers has to take lead like this, sir, actually.
Sir, YouTube live is going on now.
Yes, sir. Yeah.
Okay, you can start, sir.
Yeah. Good evening to one and all present. I'm very happy and honored to welcome all the participants and eminent faculties of Nagarjuna, and also Speaker of the Day, Engineer Rajendra Kalbhavi, sir. And I'm very happy and honored to welcome you, sir. This is the Master's Trainers Training Program in Construction Management and Engineering Economics. We have scheduled just to 4 phases. This is the 23rd lecture. 13 lectures are conducted offline. This is the 10th lecture in the online we are doing. Just as a upskilling or reskilling, or we have to give the overview of the advanced just taken place in the construction management and construction industry. What are the technologies and also other verticals required for construction engineers. In that aspect, we have arranged a series of lectures with eminent speakers online. Many are not able to come offline. That is one of the reasons. It has been coiled very well. I'll thank the Skill Center and the overall involved in this. And also, first, let me welcome our Speaker of the Day, Rajendra Kalbhavi, sir. I'm very thankful to you, sir, for accepting our invitation and sparing your valuable time with us to share a lot of information with the rich experience what you have. I welcome you, so on behalf of the center and on behalf of director and participant and my hearty welcome to you, sir. Thank you once again. And also I welcome all the Nirmithi Kendra engineers and CMTI trainees and all the postgraduate students of construction technology and BE students. And also I welcome Sanat Kumar, online coordinator of this program. And also I welcome our director, sir. He is going to join shortly for this meeting. And also just before going to the lecture, a brief introduction about Engineer Rajendra Kalbhavi, sir. Sir is graduated from the Manipal Institute of Technology, BE Civil. You all know that the #1 rated university in the India, because highly rated institute. And also, sir has got his post-graduation M.Tech in Construction Technology Management at NIT Surathkal in the year 2009 and 11. Currently, Rajendra sir is working as Executive Director, Dakshina, Kannada, Nirmithi, Kendra, NIT-K, Surathkal. Sir is having a very rich experience of almost 25 plus years of experience. And also he has involved a lot of construction activities, and he adopted Lorry Becker homes. See, Lorry Becker, I also involved 1 or 2 works in Coimbatore, sir, very near to Coimbatore. He was stayed a lightweight roofing concepts developed by Lorry Becker, and also some of the brickworks developed in Coimbatore we have used. I'm very happy to see that, sir. You are also trained, and also almost his ideas are implemented. And also Rajendra sir is an expert in alternate building technologies and eco-friendly construction area, and also constructed more than 30 individual residences, villas using eco-friendly alternative green technologies, building technologies. And also I'm happy to share this. He has trained more than 300 masons. This is the main reason the skill imparting at the level is very, very important in the construction industries, because our laborers are majority is unskilled. And congratulations, sir, for training so many masons with the new technologies. And also the sir has presented a lot of papers, reputed journals in the international, national seminars, and also journals with respect to alternate constructions, and also presented a paper in rainwater harvesting methods in Kumamoto University, Japan, and executed rainwater harvesting project more than 200 plus in all the schools and government buildings of the district. Happy, sir, and also congratulations for this. And also 80 and more talks and seminars on rainwater harvesting conservation methods, and also visited more technical guidance, you can say free guidance on water harvesting methods, more than 250 as rendered by sir, with respect to different buildings and farmlands, apartments, institutions, industries. Sir also a resource person in TV shows I've seen recently in one Akashvani studio Facebook, I've seen sir, All India Radio Talks. I'm happy to share that sir has started his own YouTube channel, Water is Life, Rajendra Kalbhavi, where practical informations are explained to implement rainwater harvesting systems. Thank you very much, sir, for your cause and also a cause for the society. Implemented rainwater harvesting structures at his office, house, and enjoy the benefits of that since 2004. Very happy to note this, I think, sir. And also, sir, is a lot of memberships. He is currently a president of Kendra Builders Association and also president of Rotary Club of Mangalore, chairman of Association of Consulting Civil Engineers 2097 to 99, and also a founder, vice president of Mangala Music Club 2010, and also a lot of trustee members with the various organizations. And also, sir, is a managing committee member of ACCI and the Institute of Engineers, IMA, ICI, many professional bodies. And also another thing is, sir is also additional drama artist of All India Radio. I'm happy to share that sir was a news leader, former CAD TV news channel, and also a lot of programs are hosted, live discussions with the local TV channels. And also he is a masters of ceremony in Kannada and English for many public and private programs, rendering voice over the video in Kannada and English. And also, sir is having many awards in his credit. Just to mention few, a national award as outstanding building center activities in 2002 to 3 by HUDCO, Delhi. Congratulations, sir. And Dr. B.R. Sabaga Young Engineer Award from the Institute of Engineers in the year 2009. Ultratech Award 2018 for well-built house in DK district. Engineers Day honors in 2019 jointly by Institute of Engineers, the Institute of Valuers, and Kodagu Udupi DK Engineers Association. And Rotary District 3118 awarded with a project that rocked for water conservation initiative. And 24th November 2020, I hope sir is going to share the glimpse of those works. And also the Ultratech Award in 2021 for well-built residential villa in rural DK. Other awards are Best Rotaract President, Best MC, Best Tanker. Very happy and honored to have you today, sir, with a rich experience, not only in technically, with also public life. And also, sir is the chairman and many district water committees. And sir is blessed with Vani Madam and children, Samartha and Samvida. Very, very happy and honored to have you today, sir. Thank you very much once again. On behalf of all our participants, we are eager to know much about all your works with respect to sustainable construction with efficient usage of water. I always tell that my water is the main, is a natural resources. It is our duty to save water. It's a natural resource and recycle, reuse. Otherwise, we are going to face a lot of issues in later stage. And now I request you to take over the session, sir. I don't want to be more in my side. Thank you very much once again, sir.
Thank you very much, Vintage Babu sir, for your kind words. And I hope my wife would have been listening now. She would have been very happy. So elaborate, so nice. She never saw my biodata. Okay, whatever I tell, she just used to give it to somebody, whoever I say, put in a cover and keep it. She used to give. Nowadays, we have mail. She and actually such elaborate, and you have almost covered all the topics. So nice of you.
Thank you. Thank you. Thank you. So, actually, we should know, all the participants should know, because they are all coming across the Karnataka. Even some of the master programs don't join from Coimbatore and Tamil Nadu, sir, because they need your service also later, technology, any discussions. Thank you, sir.
So nice, sir. It was nice to be in interact with you. And my dear friends, all the participants, I would like to tell you, it is not easy to sit and hear for 2 hours. I know that. Let me be very frank. I'm also a student like you. I also keep learning. I also keep attending seminars. It's not possible to practically sit tight for 2 hours. No. So what I've done is I have covered my whole session with various subsections, and in between we have few videos. So we can relax in between, and whenever you listen, if you have any comments, please post it to the organizer. Let them post it to me. And so that in between the videos, I can just go through the questions and I can answer. So that if at all, if it is interactive sessions, then only it will be interesting. Otherwise, it will be boring.
Yes, I request all the participants, please make use of the chat box. You can post. Otherwise, Sanath will take one by one, or sir will observe and will break the session and will take the issues. Don't forget. Please.
So one more request to all the participants that please, whenever you have a question in your mind during the course of my discussion, during the course of my presentation, please put it in the chat box. My chat box is live. You can post it to everyone, or you can post it in particular in my name. No problem. If you post in both things comes to me. And if you want to post in to the organizer, I don't mind. They will post it to me again. But I expect at least around 20-25 questions from around 40 odd students, participants, and I'll be, because it will be more interactive sessions all the way. If it was a live session where we have to offline, and it would have been more interesting interacting with you people, asking questions and further going deep into your level of thinking, and then giving you the ideas and inputs about efficient usage of water in the sustainable construction. So, well, let me do my best. One second. Yes. First, let me acknowledge all the persons who have given me the stuff to put into this presentation. I acknowledge everything, but it is not for commercial. It's only for knowledge sharing and my service for water, basically. It might be in the construction industry or for conservation. It is free of cost, or in and around Mangalore as well as in Karnataka. And whenever we say water everywhere, it's a common question. You always listen this word, water everywhere, not a drop to drink. You know who has said this message? One man way back, centuries back, wanted to invent India, and he all the way went to from of course US. He wanted to search and come in. He had heard about India. He didn't know where India was, and during those days, he wanted to venture into the sea and find out where India is. Vasco da Gama. And what happened? In due course of time, he couldn't find India. After all, then he was stuck in between, in the sea, and there was absolutely no water to drink. Imagine the situation: you're in the middle of the sea or in the middle of a desert and absolutely no water with you, and there's nobody all around. Then how would you live? How would you survive? Yes, that is why we need to take care of it. That is why we need to take care of water in each and every step. Well, Vasco da Gama survived because there was sudden rain in the evening. Though he has to stay till the night, in the evening there was a rain, and he collected it, he harvested it, and he felt very happy. So then he survived. And then the story goes on. Well, sustainability and sustainable construction. We are all civil engineers. So we need to think in those directions in the initial stage. So what do the guidelines say? What do the guidelines say? It is the state in which the components of ecosystem and their functions are maintained for the present and future generations. The component of ecosystem. What are the components of ecosystems? If we can really think about it, right, the basic thing is air, water, light, the greenery, the surroundings, the place we live. We need to maintain that ecosystems so that, it is not only for us, only the future generations also can enjoy the beautiful part of our nature. Well, the theory is all right. Let's see how practical it is possible. Well, one man and water starts way back in the age-old Adam and Eve period, or in the Stone Age, where man has not seen his face itself. So the first time his relation started with water when he saw his face. Then he started drinking it, then he started living it. So it's all a history. So man used to go near the water. He used to go near the water, get water, and live near the water surface, water area. And that is why we have civilizations named after the river. It might be Indus, it might be Nile, it might be anything in the world. It is all named after the river just because people lived near the river belt. Moreover, people also used to carry water themselves and they knew the value of water. Of late, what happened? Science started coming in. So as the science came in, people started living away from the water. The city started developing. People are not bothered whether we are living with water, we are living away from water, and we have all the facility now. We have the pipe system, we have the pump system. Even if you are hundreds and hundreds of kilometers away, you can get water from a water source. You don't know where the water coming from, but you have a water source in your house. So it is, yes, you're going away from the nature. You are going away from the ecosystem. You are going away from the basic system, what is called as the environment. So, well, urbanization is one of the reasons we can't get away with that. We have to live with that. But how to live with that? So we need to see that water is for all. That concept has to come into our mind. That has to go inside, deep into our mind and body, that water is for all, not for just for us. Well, how is that possible? Are we using the proper usage? Are we overusing the water? Let's see during course of presentation. Well, if you don't have, if you're overusing it, there is something called as reduce, reuse, recycle. Then what? Restrict. Then we have what is called as restrain. Then you have what is called as refrain. Then we have reject. Then we can many and goes on. It can go on. Well, finally, we all have to work towards sustainability. Not only our construction, the water usage also. Well, coming to the point. Somebody is in the waiting. Okay. People think, whoever it is, all the designers, all the engineers, architects, planners, the water is there. The sky is giving and the ground is there. The sky is giving, the ground is taking it, and finally it is for us. Because we have what is called as groundwater. Is it all for us? Is the groundwater sufficient for all for us? Can we have enough groundwater as we wish? Mind you, friends, this is the only planet in the universe that has water. People think we can go to moon, we can go to Mars, whatever it is only the earth which has water, and we need to take care of it. And because we live in this entire world, we have only three essential things. We need to live with three essential things. The rest comes later. Not roti, kapda, or makan. I knew you would think on those lines. No, it is air, light, and water. Air is there 24 hours, 365 days. No problem. If it is no air, at least you have a fan, you can switch off and you can feel the air. Light, 12 hours a day you have. But water, yes, it is only for 4 months. And we need to balance for next 8 months. The nature gives a warning here itself that, my dear friend, hey, my dear fellow, my dear fellow human being, I'm giving you water. I'll give you water, sufficient water, depending on your ecosystem. For 4 months, sufficient water I'll give you, but it's up to you to live happily the balance 8 months. In some places, it is 6 months of rainy season. In some places, it is 4 months. Some places are 2 months or 3 months. But we need to live balanced dry seasons very effectively. How is it possible? When human being is also similar, he has got a lot of water in his body. If he can live, there's a lot of water in his body, and he needs water again. But he still can live in all these bloody diverted conditions. This whole world can also live. But how is that? Let's see. We need to analyze the total quantity of water available in this world. What is the quantity available in this world? Many people must have gone through this. What is the quantity of total quantity of available in this world is almost, we have a lot of water all around. And because we can see, we have learned and we have seen water all around. But 97% is saline, that's seawater. and balance 3% is potable water. Out of that balance potable 3% we can get 1.2% only because others are in glaciers, ice, deep inside the ground, and so on and so forth. It's not available for you to drink. And we have water in the lakes and streams and rivers. So that is drinkable. That's the only thing. And of course, what you drink up to the well, which can humanly, you can dig and collect water, that is only available for you, my dear friend, and not the borewell. I'll come back to that later. So that 3% is only that much. You can see around small water. The total quantity, the entire world is filled with water, and the small quantity of 3% is only available for us. So that is why we need to take care of water. See, here is a very clear picture, the details, graphical example here. Total global water, 97%. And said, balance 3%. You have clean water. Then out of that, we have something in glaciers, that is groundwater. Out of the groundwater, again 70%, then 20% in lake, and balance, all this water is available for you. And if you exhaust that, then you have to rely on groundwater. And if you exhaust the groundwater, then you need to reach for the glaciers. That is what is happening. Because people explore too much of water, because people go deep into the ground, explore groundwater. They even try to take the glaciers down and try to get water. Nature is accepting it and giving you because of the global warming. We have all learned that because of the global warming, ice glaciers are melting down, and there are many cities which are going to get drowned in the future days. No wonder. This is what may happen if we go ulta in this direction. Let's not do that. Let's try to be in the normal state. But how we can? Yes. See, this is very interesting. On a daily needs, how much water you need? How much water we need? If I had asked you a live question, you would have answered. Anybody, if you know, you can put it in their chat. How much water a person needs for the day-to-day life? I have given the percentage, and what is the government target I have given here. Exactly what is the number of liters per person, per candidate is needed per person per day to satisfy his day-to-day needs, including washing, drinking, everything. So let me see. So
150 liters, sir.
Yeah, it is 135 liters written there, Baba. Very nice. It is not 135. So 135 liters is the government target to supply 130 liters per day per person in urban areas, 100 liters in semi-urban areas, 80 liters per person per day in rural areas. See, even 80 liters people can survive. So is that 80 liters is the quantity of water required per person per day? I'll tell you, it's very interesting. As research has been done, what's that? And research has been done, and they have found out that each person, though the government gives you 130 liters per person per day in the urban areas, in the cities, in the Bangalore, Mysuru, everywhere, they are targeting to give. But what the person they are using, it is around 250 to 350 liters per person per day. We are using that much quantity of water for car washing, for ground washing, for unnecessary gardening, for house cleaning, which was not required. Car washing, you don't have to use your spray. There are the best methods there are ground washing, you use pump to spray, spend a lot of water. Totally, you use around 250 to 350 liters per person per day. But what does UNO says? World Health Organization. It's still interesting. According to World Health Organization, it is 20 liters per person per day for hygienic needs. You add another 20 liters per person per day for basic washing needs or your cooking. Another 20 liters. 50 to 60 liters, if you could manage, there wouldn't have been a water problem in this world so far, because we are all responsible for this and we are facing the water problem. Take it from me. Well, come to this point. When there's no water, naturally we look towards the sky for water. Then even a drop of water matters a lot. Yes. But when the skies deny pouring water, when there's delay in monsoon, and when you need of water, what you do? You go deep into the ground. But how do you can go? Because you have science and technology, you think that you can go 1,000. Now already you have reached 1,000 feet. In my area where we have very good rainfall, it was 300 feet itself is a big thing. People, we used to imagine 300 feet deep into the ground. Oh my God. And now we have reached 1,000 feet below. And people claim that we have reached 1,200 feet. They claim it as a pride. And they are ready to go another 300 feet below. Are we not blaming ourselves? This is not a shame to say that I'm going 1,500 feet away just to take water rather than not giving anything back to the nature. What a nonsense. You mean to say, even if you go 1,500 feet deep, are you sure that you will get a very clear and enough water? Are you sure you will get pure water, potable water, drinking water? No, you don't get it. So there are chances that you get a lot of minerals in that. You get a lot of minerals and so on and so forth. So what you have to do? Here is the answer. I'll tell you. So history has taught us to be near the water, but science has taken away. And we have taken the water to our doorstep. We have enough pipeline. We have enough thing. We have, even if it is a deep in the ground, we can take the pipeline and take the water out. That is what we think. We are very smart. And once the pipeline has started, water coming into our doorstep, into our kitchen, into our bathroom, we have forgotten totally what is our water source itself. The problem is here. We don't know what is the water source. We think water coming in the pipeline itself is water and not the other. The problem is here. Very, very sorry to show this photograph. You have 1.5 feet water below your foot, in your knees up to the knee level. And to carry potable water, you go all the way, far away, and to near a tap to collect water. Is it required? Is it not possible to collect the water, what is available from the roof, and use it for drinking? So simple it is. So why the drought conditions are increasing in the country? There's a study. It says in the 2002, it was only 26. In 2019, it is almost 50%. Even otherwise, almost 50% of the India is facing drought conditions. It is not that. Of course, there are population increase and increase in population from 50 to 2020. That is also a reason. But is it that the reason? Are we not educating the people when the population is also increasing? Are we not educating the people in the right manner so that, they need to live in this world happily? We need to ask questions for ourselves. See, in earlier days, we used to see water everywhere. Everywhere there was water. There was enough water for everybody. And wells were the wonderful source of water. When the earlier kings, even during the British period, it was only the well and open well and the lakes and nothing else was the source of water for human being. And slowly what happened? Hardly, around 60 to 80 years back, we started drilling borewell. Once the borewell started and the pipeline started coming home, we started seeing the water only in the pipe. Then slowly what happened? Nowadays in the cities, people see water only in the plastic bottles. It is common in Bengaluru, common in Bombay, common in Chennai. I have seen people living only with plastic bottle water. I don't know what will happen. The same thing happens. You please read on. I don't have to tell anything. So what is the solution? What's happening to water? Water has become invisible. The water is becoming gayab. I don't know where it will go. Now it's time to make it visible. So let's get into real business of making invisible to visible. So, and there are what are the reasons for invisible is the depleted quality, the scarcity, excessive use, depletion of groundwater level, drought, wastage, water pollution. Have you seen that there are human-made reasons are that depleted quality is because of your excessive usage, scarcity is again because we are not saving it, excessive use because we are not taking care of it, groundwater level has depleted because we are using borewell pumps, drought has come because we are not making Mother Earth soft and clean. We are wasting water, we are polluting water. It's all our own, within our own hands. And we blame nature, we blame public, we blame others, saying that water is not there, water's quality has gone bad. And of course, to make it visible, all these things are there, which I will not tell, because we are not following, many of us. Some are doing it, but now it has become a big business in India, all over the world. So friends, what is it? So what is harvesting? So whenever you call about talk about water saving, people only think of water harvesting. So let me finish that subject of water harvesting. It is beyond water harvesting. There's a lot of things beyond harvesting. So, but anyway, so correction of water is harvesting. When the water falls on your roof, you collect it, filter it. Either you keep it in your sump tank, or you charge your borewell or your open well. Or if you don't have both, put it in a pit in the ground, allow the water to go into the groundwater table. Borewell recharge, you can do it directly or indirectly. Then groundwater recharge, again, there are different methods. Like, percolation pit is the best. Short, long, deep percolation pits. Saving of water bodies, not polluting it. That is very important. Watershed development. When if you cut a tree also for development, develop another watershed area so that water is there in that area. And finally, it is the efficient usage of water very, very properly and very efficiently. When you have a lot of water, when you have a lot of money, you spend a lot of money, right? Yes, you do it. But you don't spend all the money. We have a lot of water now. Just because that we can spend everything? No. We need to take care of it. We need to do it very, very efficient manner. Water and money goes together. Then only you can save water. Well, if you can go through the episode number 6, basics of rainwater harvesting in Water is Life channel, you will get these details. What are the different methods of rainwater harvesting? Well, I'll tell you, who has to do rainwater harvesting, what you have to do, where you have to do, when you have to do, with what you have to do, is a common question. People ask, sir, how to do rainwater harvesting? I'll show you this video. It's very simple. So this is a wonderful video explaining you how to do rainwater harvesting. That's all. Whatever you get, with whatever material, wherever you are, with whichever items we have, just collect the water and rainwater, because rainwater is the purest form of water available for you. It's not a rocket science. It is common sense. You don't have to be a technically qualified to understand water and water saving techniques. It is pure common sense. Chalo, now we'll go forward. Now coming to sustainability, because sustainability main relies on three pillars: the economic, and the economics, just because water is a big issue, many construction has stopped. Because water is not available, people have to fight even for the land, the nearby area, this, that, and all. Especially in the construction of houses, this is the big issue. Water is not available. Either your neighbor will not help you. He will not give you current also if you have one during construction. So the economic activity, the world is moving only because of economics, and it is lying with the sustainability construction. And socio-cultural identity also is because of this. So because of this, the social cultural identity is also there, and environmental, which is common to everyone. So if you control economic, socio-cultural, environmental aspects, probably the sustainability will be more effective. So globally, what is our contribution? So especially construction contributes 40% of the energy. We not only consume, when we do construction, we give 40% of energy out. We also consume 40% of the water also in a regular requirement. For a normal construction and other things, domestic, irrigation, 42% we can use for construction. So 50% of the raw material, air pollution, and so on and so forth. And of course, we contribute to 50% water pollution also. Because of all the construction waste, dust, plastic, it is finally they dumped into the beds of the river. I'm very sorry to say that. We don't know. We give a hamali, or we give a coolie fellow or a contractor to take the materials out from our site. You just take it away, and we give him $1,500 or 2,000 rupees per load. And he brings men and material, collects all your dump and takes it away. We never bother to ask, where are you taking it? Where are you dumping it? He is dumping into the riverbed. Oh my God, the greenhouse gases, solid waste, etc., all these things. See, you can make out very clear, all our constructions is giving heat. It might be heat from the surface of the road, the vehicles, from the floor, and from the temperature increase from the buildings, and all the air conditioners, etc., etc. It's only the trees, it's the rivers, only gives you the cool air. So we need to sustain along with the urban growing city, urban environment. So the water scarcity in India, I don't have to highlight much on this because you have read everything in this in your newspapers. You know everything. This is common in the newspapers nowadays. Every now and then, every summer, there is an article saying that water is scarce. We are going to get into problems. And everybody has given a target of 5 years, 25, 27. Many cities, especially Chennai and Bangalore and many other cities are going to get dry. They're going to dry up. I don't know. If you don't take care, you're going to face problems. So, but still, Chennai is somehow managing now because they have done a lot of water harvesting and they have taken measures to increase the groundwater table. So that thing is, then things will go on. So growing water demand means growing scarcity also, because I've told you only 1.2% of water is available. This whole world for us. So the growing demand is like this, 2025, we are in this level and it's going to increase further. The average consumption of water, billion cubic meter per capacity, cubic meter, is this much. So here it is. So irrigation takes the major quantity of water. There's an argument happening, but irrigation also allows you to water to percolate into the ground. But efficient usage of water in irrigation also helps a lot. Then we have drinking, then we have irrigation, industry, energy, and others. They contribute all other 30%, 40%. How much water we get and where does it go? See, we have houses. We have houses of say 1,000 square meters, or 100 square meter. We are living in houses of minimum 100 square meter. So 1 square meter of 1 mm of water, of 1 square mm, 1 square meter and 1 mm. Just 1 mm water will give you 1 liter. Suppose India's average rainfall is 1,200 millimeters. Forget about it. We'll take about Bombay or Bangalore only, say 900 to 1,000 millimeters of average rainfall per year. So 1 square meter or into 1,000 mm is equal to 1,000 liters. Very simple. 1 square meter, you will get you 1,000 liters. If you are 10 square meters, then 100 square meters you will get. Because we call here all square feet in Mangalore. So it is only 1,000 square feet house or 2,000 square feet house. Like in Bangalore, they call it 10 square house, 100 square house. So that's why I'm getting confused. Don't worry. So 1,000 square feet house or 100 square meters will give you 1,000 millimeters, will give you 1 lakh liters. If you can collect 1 lakh liters, there's nothing like that. Forget about the cost of the tank, I'm not talking about, but you get that much amount of water free of cost. That is what is important. In 1 acre, we have 10 lakhs liters. Well, it's interesting. Now, okay, we get that much of water, but how we are using it, how we can get benefit for our purpose. Suppose there are 4 members in a house. We just calculate in a simple way. 4 members needs, say, 100 liters per day. I said 80, but 100 liters per day. If you calculate, it is 365 days, you need 1,46,000 liters. Just 1,46,000 liters annually. By gift of nature, it is 1,25,000 liters annual rainfall. It is India's annual rainfall, average annual rainfall. Mangalore is much higher. So the difference in volume of water is 26,000 liters per annum. Whatever it is, if you calculate liters of water per head, it is almost 17 liters per head per day. 26,000. But 4 members, 1,46,000 liters, you divide, you get 26,000 liters per day. And still, I feel we are much near the average annual requirement of the hygienic needs for a human being as per World Health Organization. What is the minimum quantity of water needed for a man to satisfy the basic needs? Here it is. At a higher quantity of water, about 20 liters per capita per day should be assured to take care of the basic hygiene needs and the basic food hygiene. Laundry, bathing might require higher amount of it unless carried out at source. So only that's what I said. Laundry and bathing, you add another 40 liters, the 60 liters. So 60 to 80 liters per day, if you can manage yourself, there will be no water crisis in this world. Well, how do you do rainwater harvesting? Well, I can say we get 1 lakh liters or 1,40,000 liters in Bangalore. We get 3,50,000 liters, 3.5 lakh liters of water. Such a big treasure is falling on our head. We need to know how to collect it. Interlink everything. Interlink. All the outlet, just don't leave it open. Interlink it, bring it down, and make a first flush. You keep it's closed here, make it open. Here also, if it is a tile roof, all interlink it, and then bring it here down. And when it comes down, here you use a first flush. As I said, it's also closed here. You open it. Generally, it is kept open during the summer, and all the first rain wastage will go outside. In the first rain, all the dust particles, bird dropping, etc. will go. And finally, when the heavy rain starts, you can close it and water goes into we have a sump tank. This is my office. And this is my friend's apartment. And this is the drum filter they have used. So you should never forget a first rain separator. So this is how, when it's heavy raining in a multi-story building, we did it for the multi-story building. See the amount of water. That's only a first rain separator. Whatever collected in that only will go and it all separate. Now the heavy rain is happening because you can see the water in the drain. When the heavy rain, we just opened it. So see that in whether any dust particles collected in the first rain separator. If there's no dust particles, then absolutely no problem. You can allow the water go into your bore well or the sump tank. See here, this is very clearly, this first rain separator is with a knob. You close it, it will go through the filter, then from filter, it goes into the well. Very, very simple. I've got a video, number 7, which explains very clear about first rain separator. Okay, now what are the types of filters? There are different types of filters, my dear friends. This is all available in the market. But only problem I have seen with the public is that they just collect the filter, install it, the plumber will do, he will do the installation and he will go. Finally, people doesn't know how to maintain the filter. There is everything like our human body. There is a small piece of maintenance every filter has. So some filter, you don't have to maintain it immediately, but at least once in a year, you need to maintain. Some filters, they need to maintain regularly, keep an eye on that, see that the sludge is not collected too much, that is, doesn't block the way of the water, and so on and so forth. There are simple filters like pop-up filters, what you are by KCST. It is very simple, but you need to maintain it, clean it once in a year. And at the base, you can see this is my house. This is episode number 8. We'll tell you what are the types of filters and what are the types of what the filters do, how you can prepare your own filter. This filter you can prepare yourself. It's very easy because it is nothing available materials in the ground only. If you want to know, you can go to the next episode number 9 or something, which tells you what are the types. And this is a sand bed. This is the drawing of a sand bed filter. This is how it looks. In different varieties of boulders, you put it, and finally Netlon mesh, then coal, then Netlon mesh, and leave the small space for open for the headroom for the water to collect there. And you got pure water, you can let into your borewell. Episode number 9, I said you can get very clear idea on how to make a drum filter by yourself. You can make it yourself, nothing. This is a very simple. This is my house, my dear friend. I have done rainwater harvesting for the past almost 22 years now. From 2000, I have been doing it. 2001 and 2002 almost. It's not 20 years down the line. And absolutely no problem. I am drinking well water without boiling, without filtering. Well, let's get into other aspects. Now, if you don't have a well, you don't have a borewell, you have what is called as a percolation pit. This is a pit which you can do it in your own house when there is no area, where there is a small length, you can put this percolation pit and see that water goes into the ground. This is another percolation pit where you can allow water to get into the ground and it will stay there in the ring, in the well, and it will get percolated in the sideways. This is common thing and is very, very effective and very useful. And if water is too much, then you make a deeper hole. When you have the capacity to make a bore well of 300, 600, 1,000 feet below, make a percolation pit of 30 feet. No, who stops you? And you can allow the water to go in. Well, and here's a simple method which you can do during construction. This is a small building, but see. See that percolation pit. It absorbs water. It never overflow. This is what we can do in a construction site also. Our laborers wash their hands. Our laborers take bath. And we allow the water to go and it will spoil the surface of our construction site, and a lot of mosquitoes will come around. Instead of that, just allow it to go into the percolation pit. If you are in a house, you can do similar type of percolation pits. Absolutely no problem. And later cover it. You can use the surface. It might be a lawn, whatever it is. Then this is my house again, and we have done a percolation pit at the exit. This is the main gate. And next, I've made a diversion. I've made a percolation pit. See, this is not a ring, and I kept a hole there, and I covered the top. I'm using the top surface. And this is the cushion area where I've filled it with all the waste, jelly, gilly, and stones and all. You're not losing your garden space. You cover this drain also. You can cover this drain also, that the entire space is available for you. And water goes through the drain, enters into the pit, stays there, and get absorbed into the ground. Very simple. And this is at the back side. This is done during construction only. It need not be always round. It can be square also. It can be rectangle also. An old leach pit was available. I made it a little bit shorter, created a buffer zone, and I did a percolation pit. And very important at the base, you need to put a boulders like this so that the silt does not form and the water will not block water entering into the ground. So simple. It can take lakhs and lakhs of water. Okay, I will go further. And if you have a very big building, this is other what do you call other percolation pit which we have covered. Yes, see what we have done at the sites, and you can see the water getting into the percolation pit. So with a huge building, that building can give you an annual 50 lakh liters of water. So it is a huge quantity of water. I have made it into getting into two percolation pits. This is one at the bottom. This is the second percolation pit. Just have a look at it. So these types of percolation pits can take lots quantity of water, especially in a construction site. Can't we do that? And we struggle for water. Why should we struggle for water? And this is wonderful machine, Borewell. Huh? This is interesting. See the quantity of water coming out. And with that much of quantity of water, we take it from the ground and we are never bothered to give water into the ground. And there we go wrong. See, if you look at the earth structure, earth behaves like a sponge. And we thought there is a huge quantity, there is a huge lake below the ground where we can take more, that sufficient quantity of water for us to meet our all greedy. No, it doesn't. It's not like that. It is just like, it's a sponge, and you are digging a hole in the sponge and you're squeezing the water out. In a given rainy season, Water can enter up to a feet of say 60 to 100 feet only. Beyond that, it cannot go down. Then it takes its own time, sweet time, to go deep, deep into the borewell. It takes years and years together. And we insert a pump and take it all within say 10-15 minutes. So the water which falls on the ground can go up to say 50 to 100 feet in a given rainy season in 1 year. Then you can extract it, take it out in a year. And once it's water goes down, water table goes down, then again rain has to come, then you refill it, then you do water harvesting, and you can use it again. That's a wonderful cycle. And if depending on the condition of the ground surface, water stays, and that is why the lakes are formed. Okay. Now, if you can go through this, the effect of a borewell is very, very bad. People say it's very easy to think about a borewell because if it is all were open well, everybody will get water. If all were open well, everybody will get water. And if in a given layout, if one man does a borewell, because of the high pressure pump, a cone of depression will start, and even the open well will go dry. That is why heavy pumping is very, very dangerous for groundwater. Very, very dangerous. How do we do that? How we can recharge a borewell? It's very simple. See, this is the borewell which has been dug. Tighten the base. Then you drill. Small drills are to be done, and drill men's holes has to be done. Cover it with netlon mesh. Then bigger size stones, then smaller size stones, then a netlon mesh, then coal like this, that is around 4 to 6 inches thick you have to put. Then again a layer of netlon mesh, then cover it, and like this, make a stand platform and allow the water to go into the borewell. And you will be surprised to see the amount of water getting into the borewell, deep into the ground. The deep aquifer, it's so much superb. It's awesome. See the quantity of water is getting in. It slowly drips into the ground, absolutely directly deep into the mother's stomach. Absolutely no problem. Like this, if you start feeding your groundwater, then you have the right to take water also. You don't feed, you only want to take. Like in a bank account, if you put money only, you can take it out. Without putting money into the bank, you cannot take the money out. So you need to recharge. That's the basic thing. Recharge your mobile, recharge your bank account, and why not recharge your ground? Well, this is very, very popular episode of Water is Life, episode number 11, how to recharge a borewell. And there is my YouTube channel. It is very hardly hit. And please go through it, and it is very nice. Give your comments, share it with your friends, press like button, and so on and so forth. Now, there is again a question asking people how much we should recharge, how much we will get back. Are you sure we can only get back whatever we have recharged? Here's an answer. just says pour water into the borewell. It works. He is thirsty like dead body, whether to drink or to pour into the borewell. So it's very simple. It says humanity cannot survive if greedy does not die. The water has to be shared among everybody. We cannot be very greedy. We engineers have to think it 100 times, especially in our construction. Well, coming to the point, yesterday we had a lot of discussions on the IGBC, IGBC ratings and Indian Green Building Council and all. I don't know whether you had a discussion on these points, what IGBC was telling. Have you noted that the water conservation points and energy efficient points, they have other points also. They have a big list. And out of that, what rate the highest ratings, which has got the highest points? Have you ever observed? If you had observed, you would have realized that it would have been really nice. If you had observed, you have one more interesting things to happen. 1 minute. Thank you for your feedback, my dear friends. See, the IGBC ratings clearly tell you that water conservation stands the highest in all the IGBC rating points. If you need an IGBC ratings in the total category to get an green building gold-plated certificate, it is water which plays a very important role. Rest it's manageable. You can make it. Energy efficient is next. It is 20. That's why it comes in the series. So these are must. Water efficient plumbing fixture, rainwater harvesting, it is must. Water efficient plumbing fixtures will cost you so many points. Landscape design is there, management of irrigation system, recycling and reuse. We can talk all these things. I can give you a lot of information. Then water quality, of course, I'm not a chemical engineer. Enhanced water harvesting, that's also very easy. Water metering, that is also interesting. I can give you some examples in this period. What happened? It's getting stuck. See, the materials and resources you use carries 18%. Resident health and well-being, if people are happy after the construction and if their well-being is good, 14% of the marks goes into that. Innovative design is just 5%. Innovative design is called innovative if at all it has got water harvesting and energy efficient. And only it become innovative. Because 43% is only this. Then rest is sustainable design, 20%. How is your construction or a design is sustainable and it can be part of the ecosystem? Then it becomes innovative. So this is how the green building concept works and how I'm thinking and what are we doing. I'll just tell you. Total water usage in construction is something like that. Water used per unit area of the construction largely remains undocumented. It is not undocumented. We are not bothered. Any engineering company, any engineering college, any university, if they build a building, nobody is measuring what is the quantity of water is being used for the construction of that building. So that is the state of affairs here, because we are no, but there are some studies, very nominal studies have been done, because it says we need around 27,000 liters per square meter of building construction. The whole building is around 1 lakh square meter. Imagine the quantity of water required. 20,000 kilo, 27,000 liters per square meter. If it is 1 lakh, calculate. Just 1,000 itself is enough. You'll get 27,000 liters. What if just for 1,000 square meters building? So actual construction, they say as per calculation, if you can make as per your adequacy requirement, as per your what your calculations we have. We know we calculate adequacy. What is the cement steel required for the building? And the same way we can calculate what is the water quantity required. It is just 2,000 liters per square meter. But actually it's 27,000 liters. That means say 20 times more. Well, need to have water efficiency. It has to be in the production stage, construction stage, as well as usage stage. Then it is the total cycle of the building. You need to calculate the water usage. Then only it became important. Actions at the consumption stage. That's the production stage, consumption stage, and usage stage. All their efficiency has to be there. But they say 20 kiloliters, that is 20,000 liters is required for a building. That is what they say. Practically, this happens. Well, designing as a whole unit, concern as a stakeholder, what we need to do, our design has to be a 360-degree beautiful. 360-degree, it has to be correct. And we should not harm the eco-sensitive sites. Suppose we have, which is a building has to be built in a hillock. Just because we are doing a building, you break up on the hillock, make the level it, and then do a building, then probably the earth behind the hillock, what you have leveled it, might fall off or cave in any time. So you need to build a big retaining wall. You spend a lot, and finally, even that retaining wall might slide down one day. We don't know. So you need to be very careful. Now, like lake, forest, lake, canals, etc., has to be taken care of. Wildlife corridors, wetland, floodland has to be avoided. IGBC guidelines has to be taken care of. Then you will be designing your buildings in line with the ecosystem. So whenever you build a plant, that is why you need to, when the construction is going on, if possible, you build grow the greenery also together. And you make the proper total provision for the greenery also. Any plant utilizes 2% of the water. Water you're putting into the plant. 2% of water is only utilized for making food. Or if it is giving a fruit, it is only for 2% of the water it will use for making your water for the mangoes, what you eat. Balance 19% is to maintain the temperature of the environment nearby. That is why we feel very comfortable when we go near a tree. And if it is a very hot summer also, if we go near a tree shade, we'll be very comfortable there. There is a reason, because it gives comfort to the people. With 98% of the water it is used. So protecting environment is not a joke. It is not, it doesn't come out very easily. It comes at a cost. So we need to take care very, very carefully that, development footprints, we need to do it very minimum. Look at the building, preserve the site, natural areas. We cannot go on doing it. So sensitive constructions as well as sensitive usage of water, everything comes together. And if you don't do that, this is the problem. This is the problem. Earth will act according to its will and wish. So let's be very careful when we do our buildings in future. Coming to civil engineering now, designing the material. What are the types of material we use? What are the type of material which gives less water? What are these sustainable constructions? Let's see. See, first, when you design a building also, it has to be, if the water has to be used less in the construction, then it contains a lot of open space, number of less walls, and the wall length has to be little, and there should be free movement of space. People are comfortable. People once going into the room or house, they should not feel very hot. And they should not feel uncomfortable so that they drink more water. No, use more. When they drink more water, no use. Man will only go to the washrooms regularly, nothing else. So let not that happen. Your designing has to be very space efficient, and you should use only local available materials, because every temperature in a particular area and the environment conditions varies depending on the place. For example, in Mangalore, it's a very hot and humid place, and you bring all the way material from Rajasthan and put it, you will have your own problems. People complain about knee joints. People complain about too much of cold or too much of hot, so on and so forth. So locally available materials is the best solution. So, and local techniques. For example, what you're seeing here is a mud block building. Is a mud block building. And you can see arches there. You can see exposed masonry there. You can see filler slab, where you have less quantity of steel and cement, and so that it will not give you more heat, and you feel comfortable inside, you use less quantity. So the circle is complete. You have then, what are the different eco-friendly construction? Apart from using locally available materials, you need to avoid less steel and cement, which will give you more heat. Then now, what are the techniques? If we start from the ground, we have arch foundation. Of course, you're all from civil engineering, you're all from Nirmithi concept, then we have come across this arch foundation. Then instead of using lintels, too much of lintels is too much of steel and cement. Avoid lintels, use arches, beams. Earlier days, you have seen they have built bridges using arches. When they carry so much of load, can't we carry, our arches can't carry a simple slab load? It can. Only thing is we need to do it properly. Mud block, rammed earth walls are one of the best. Gives you very comfortable interiors, less of cement, water, and exposed masonry again, filler slab, brick vault, and these are all, I don't have to explain you. People always say that no, when we use construction materials like this, when we do a construction, a normal construction, if we do it in stones and all, we at least 1 square meter of wall construction needs an average of 350 liters of water for 1 square meter. So if we don't use water at all. If this is adhesive, then you don't have to use water. This becomes zero. It will become very, very water efficient. Absolutely no problem. And people say there's a lot of wastage. So now machines are available, which will provide as a paste of chemical only on the edges, only on the surface available, and whether it's hollow, they don't. So you have a lot of efficiency there. You'll save a lot of materials, and these types of clay blocks, we can construct almost with very, very minimum cement joints. There are concrete blocks, again consume less, and we have what is called as interlocking blocks, which again it hardly consumes any cement mortar, absolutely no mortar required. And I have constructed. This is my own construction. I don't preach which I don't know. So this is my construction. See, these type of mud blocks we have used, and this is not a cement mortar, it is a cement slurry. And you can see there is absolutely no slurry anywhere. It is just blocks laid one above the other, interlocking mud blocks. And the house can be completed very nicely. It looks very beautiful. See this. And the people are very happy with that. The motorless construction, absolutely no motor. Only we use cement concrete for the slabs, roofs, and little bit of arches we have used. I have to agree with that. This ferro cement again for Nirmithi engineers is not a new. See, earlier ferro cement racks were like this, with a lot of masonry and again tiles. Now it's so simple and sleek. We just paint it with putty finish and give it a beautiful color. You don't need a paneling, or you don't need to put tiles at all. It looks so beautiful, smooth, clean. And it can be done for large scale and small scale sector also. In variety, it's custom design, absolutely no problem. So why do we need plaster? No, we don't need to plaster at all. The plaster consumes a lot of water. You need to use plaster for not only curing, you need to water for mixing. To avoid quantity of water, how do we reduce 20,000 liters per square meter to 20 liters to, let's get come to 2,000 liters per square meter. With all these techniques, absolutely no plastering. This might be a temple or it might be a house. No plastering at all. And it will gives you dual advantage. One, saving of cement, other saving of heat, less of heat, and comfortableness, less usage of water. It might be a ground floor building, first floor building, any building. Absolutely no problem. It might be a government structure or private residence. Follow the technique of exposed masonry or zero plastering building. Or it might be our own office. This is our own office, friends. You are most welcome. Anytime you can come here to have an interaction with us. And this is a central government building. Can you imagine a central government enterprise giving us permission to construct an exposed masonry work with our latest techniques? This is Konkan Railway running room at Surathkal railway station. Konkan Railway Corporation has given us this work, and they wanted to do work in different taluks, different districts. But unfortunately, we were not permitted to go beyond our district, so we stopped there. Okay, this is a multi-storied building. You only think of non-plastered buildings only for ground floor? No, we can do it for multi-storied buildings also. Absolutely no problem. With this heavy rainfall in Dakshina Kannada, in Mangalore, we don't have problems with exposed masonry because we take care of quality of work is very good and people are very happy. And this is a very old building, maybe 10-15 years. Even the department has not bothered to plaster it now because they're very happy with the exterior. Well, again, Nirmithi engineers, you all know this, filler slab, less usage of cement, less usage of cement and steel, then not only the usage of water also will come down, the interiors will look good. This is with the filler slab, with the clay or mangled tiles. This is the hollow clay blocks. Then we have what is called as clay hollow blocks. Then we have what is called a bricks. Then we have pots. We have bottles. We have coconut shells. We can construct filler slab with different materials. Absolutely no problem. But this is one concept which is we are only promoting. That is zero maintenance building. No plaster, no paint, no maintenance, And absolutely, we are very happy on a long run. The water, sustainable water usage will come on a long run. Absolutely no water required. Absolutely. These are all old buildings. This is the most around 30 years old now. This is around 20 years old. Absolutely, even today it looks the same. Absolutely no painting required. It is called as natural beauty of the building is maintained. Now coming to the buildings, how we can save water in the finishing. There are a lot of fittings available, especially in IGBC, water fittings, water saving fittings, they carry special marks, points. So you have to use waterless urinals, it's very good. Otherwise, very water efficient closets are available with the maximum 6 liters. Otherwise, it is 12 liters nowadays. 12 to 18 liters of water being used in the olden days. Now you can get water closet with the with maximum 6 liters per flush. You can use. There are again a mini flush in that also. Hardly 1 or 2 liters will go. Then dual pipeline for flushing. Well, this is a different concept. In Nirmithi, it's not possible. In public building, it's possible. When you have a STP or when you have a when you have a leach pit sort of a thing, septic tank, the water comes out is a clear water, and this clear water will allow you water to go into the separate tank, and that is used for flushing. This is possible. Then the push button, as I just told you, dual button flush knob, and all these things are available. There are many efficient fittings have come nowadays. There's something called as aerators. I'll show you that. Yes, and this is very efficient. So earlier days we used to get water fittings like this. All your houses, offices, public places, put this aerators. If not, these fittings are available. Please use this so that you can save water and you can live comfortably. This is one more technique what we are using. This is again in my office. We have used biodigester. We are the first to use this biodigester in the district, and which gives you very clear water, 100% recycling of water. Your toilet water is completely recycled and you get a clear water which is used for the gardening. It's a very eco-friendly solution. No power required. Power consumption is at zero and is a lifetime, zero maintenance, less space required also. And it is a clear water output. It can help greenery to develop very easily. And the existing septic tank can be converted and the water is 100% recycled. So in the sites, what all you can do, construction, best thing is do a percolation pit, maintain the existing water system flow, and runoff and all, you take care of it, and do a big percolation pit so that water is not wasted. Don't allow your water from your site to go outside, so that whatever you draw water from your borewell, it is being used for your own purpose. So we have one more now fittings available. This is again in our office. We have something called as, we have water from nowhere. That is, we get water from air, air to water machine. This machine converts humidity into water. So no plumbing required, just plug in, collect water, drink it. Very efficient and very helpful. So then these are bottle filters are available now in the market. The AquaGuard is there, one. Then Neeru filters is one available for Bangalore. It's not available here. I'm looking forward for that. If all the laborers in the construction sites can use this, they can take straight away, take the tap water, fill it and drink it. And it filters and gives you a healthy body. And your body also will remain healthy, and they can work for better digestive system. Everything will work happily. Absolutely no problem. So all you need to become and sustainable construction is you have to become water smart. Apart from using efficient water, it is you need to become water smart in every aspects of your life. So I was talking about water metering. See, this is a classic example of a city or a classic example of a village in Maharashtra, where they practice water budgeting every year. They calculate what is the water requirement for every farm. They calculate water requirement and what is the average rainfall in a year. And what is maintained called as a Panika passbook. And once they develop that Panika passbook, according to their calculation, if they have a borewell or if they have a lake, they pump water to each and every lake according to his KT or his whatever he wants to grow. And that's an amazing technique, and it has been well appreciated all over the country. We can install water flow meters, we can install water flow inflow meters, outflow meter. Have you seen anybody installing a meter to a borewell pipe and finding out how much water he has taken out? He is not bothered. He is neither puts water or nor he how much water he has taken out. None of us install a water meter for our pump for a borewell or open well. We have not done that. It is high time we calculate that also. Otherwise, only corporation will give us later water, how much we have utilized. Corporation or the government or the panchayat will give us the bill. That much of water you have utilized, this much you have to pay. Water bill will come. We have to take a bill from the nature, calculating what is the water we have collected it from the ground. Then you correlate it, see number of people into the number of houses, total, say 1,000 liters there, 20,000 liters here, total number of people divided by number of people in the house. Per day, you will come to know how much water you use. This is called water budgeting. So, water is like hard cash. As I told you, unless you recharge, whether it be an open well or a lake or a borewell, it is like a hard cash. You cannot withdraw. ATM card will never work. So it is like an SB account. So surface water is like a cash. SB account is like an ATM card, and it is a borewell. It is like an FD account. So you have to use your borewell only when your SB account gets dried up. You don't have money to put into the SB account. SB account is empty. Then you remove FD. Otherwise, you don't remove FD. Nowadays, what happens? People are not bothered whether you have SB or FD because the bank has got something called as a sweep system. Your FD will automatically get into the SB, and finally, you don't know how much you are withdrawing. You think your FD is still there, but your FD is getting dried up very fast. That's very, very dangerous. And that is what's happening. We are not bothered about our SB account. We are just taking water from our FD account. So let's be careful. So if you really work hard, you take conservation into system. Your lake, we also take up constructions. Tomorrow, we take up lake rejuvenation board works. We need to take it very carefully that how we can save the environment and lake rejuvenation. Once we do it, even 20 years back dried up Devanahalli lake can come to life. Even a 10 years old open well, which is dried up, can come to life just because you have taken rainwater harvesting methods, recharging the groundwater. Water can be everywhere very soon. So are we engineers, we are engineers, we are very smart guys, we do roads, we do everywhere interlocking. We are making this earth impervious. Earlier days, when there was no construction happening, even in the forest, imagine, or in a village, water will fall everywhere. Water from the sky falls into the ground, goes into the ground, deep into the groundwater, and you dig your open well, you take water, whatever you want, you are happy. But now what we did? We have built a road, water does not enter. Our yard work is covered with interlocks, water does not enter. So water has no place to go into the ground. Instead, now we are allowing water into the road. And when you allow water into the road, this is what's happening. There will be loss of human life. There is a lot of water flooding. This is called as urban flooding. Nowadays, it is common in Bengaluru, common in Bombay, common in Delhi also. Can't we reduce this? Can we engineers contribute ourselves by providing percolation pits in our own ground. Prime Minister has given a call called Catch the Rain when it falls, where it falls. It's a wonderful campaign our Pradhan Mantri Modi ji has taken forward. This is the second year which is running. First year, Catch the Rain campaign went on very well, and a lot of Mannarega programs were also taken place in the rural side. A lot of people were worked only on water conservation, clearing the weeds, clearing the ground, everything, and doing water harvesting, etc. Lake rejuvenation takes have happened. Borewells, lakes have cleared up. Open wells were cleaned up. So what is this? Now what we engineers can do? This is my previous episode of Catch the Rain. From the Catch the Rain campaign itself, I have done 3 videos. The third videos which will help you to reduce runoff water. Just go through this. This is only I have 19 videos. If I cannot show you everything here, I'm showing you one video. Just go through it.
Hi, Namaskar. Welcome to the Catch the Rain Part 3. In this episode, you will get all the information on how to catch the runoff water to increase the groundwater storage. Huge quantity of rainwater flows out of every compound through yards, roads and drains, and this leads to urban flooding. To prevent this, we have to make sure that no water or minimum water flows out of our compound. This is what Prime Minister Modi has said through his campaign, Catch the Rain when it falls, where it falls.
वर्षा जल का जितना बेहतर प्रबंधन करेगा उतना ही ग्राउंड वाटर पर देश की निर्भरता कम होगी.
Rainwater falling on every compound flows out into the streets. There might be more than one outlet for water to flow out of the compound. Construct a recharge well or a percolation pit near each outlet. Divert the outward flowing water into these recharge wells. Water collected in these pits will slowly seep into the ground, thus recharging the groundwater table. Construction of a recharge pit or a percolation tank is explained in detail in episode number 9 of this channel. The depth and size of the percolation tank can be varied depending on the quantity of water and the nature of soil. Water from only paved surface, concrete roads and yards should be let into these pits. Do not let water from the natural muddy ground into these percolation tanks as it leads to collection of silt and soil causing blockage. In muddy grounds, farms, estates and hilly areas, percolation pits can be simple and shallow in depth. It can be square or rectangle in shape depending on the soil condition. Every compound should stop rainwater flowing out into the streets. Then the urban flooding can be controlled to a large extent. Let us make up our mind and follow these systems as explained in this series, Catch the Rain Part 1, 2 and 3. Once done, it is a lifetime investment to recharge the groundwater table and contribute to the nature well-being. Let us join hands and give back the nature what it wants. That's all in this episode, Catch the Rain Part 3. Press the subscribe button, post your comments and share this video with your family and friends. Namaskar.
So friends, that is how we can also contribute by not avoiding and allowing runoff water into the cities. A large extent of water can be controlled. Not that we can control 100%. But to a large extent, if every house site or multi-story building or anybody, if they can do a percolation pit. Of course, we have our own restrictions. Just because I'm telling percolation pit, you cannot do it percolation pit in every place. I have done the next video, which is do's and don'ts, where the percolation pit has to be done, where the percolation pit has not to be done. Those things are also told there. That you can go through. The thing I cannot tell here. I can only a small information. Well, coming to industry, out of the total quantity of water consumption, irrigation, construction, domestic, and industry, all put together takes the balance portion of it. So industries also play a very large role in conserving and preserving water, reducing and recycling water. But you know what? The best part is industry is growing because of water, because of these aerators manufacturing, that aeration, that aerator industry is doing now very well. The water efficient fittings have been manufactured by many companies. They are doing very well. Water recycling and reusing companies are doing very well. The STP, the sewage treatment plant companies are also doing very well. There's a lot of marketing happening now to install install water efficient STPs. Then eco STPs also come in. Recycling grey water, recycling black water, that is also become a big industry. This all the mistakes we have done, and we are spending money and correcting it. But let's not do it again. No, the Ganga River recycling, all the lake rejuvenation projects are taking place in and around our city, and especially in northern parts where lake rejuvenation is taking place, where the grey water, the water is not very saline, but is not able to drink. But that water is made to the quality of a potable water is just because there is an industry come up. There are many consultants, the people working on grey water recycling, the people working on black water recycling. There are industries, and in our own New Mangalore Port Trust, which is very famous, and they have got a very efficient water treatment plant. I'm told that they are recycling the water 100%, where the BOD is so low that it can be used for drinking purpose also. That means your sewage treatment is converted into a drinking water. Say, what a big industry. Well, this is civil engineering, so we have to be very careful in our curing part, because we use a lot of water in curing. This is which is a setup for steam curing, where because of the steam water, the whole thing, the blocks, the concrete block, the concrete slabs can be cured at just 24 hours. You can get the design strength, and we are very water efficient. There are other water efficient methods, especially in the sites when we go in initial stages. We don't get purified water to drinking, and we spend a lot of money. And to avoid that, these type of water purifier systems are available, which can take really a dirty water or muddy water and convert it into pure water and give it to you for cleaning and drinking purpose. And there are agencies, there are like Rotary Alliance, really working on water efficient methods, water saving techniques. They'll all give you hands, they'll all help you. Now this is interesting. Now I've been talking about India for a long time. Now let's talk about a country. We talk a lot about Israel, and this Israel, which has got 60% of desert, and it has got only one river. And there is a country on the other side, which is zero water country called as Cape Town. Zero water. It says it has got a zero water. You Google it out, zero water city, you will get Cape Town's name on the top. So when we have a zero water city, we here is a country which says we are very rich in water. People say that if at all there's a third world war, it will be because of water. Israel says we can increase friendship because of water. What a wonderful concept. It is a very water-rich country as on today. How that is possible? How a country can be water-rich? If that country can be water-rich, can't India can be water-rich country? Earlier, India was one of the water-rich country in the world. That is why we were called as Sujalam, Sufalam, Malayaja, Shitalam, Sasya, Shamala. What happened now? Over the years, we have neglected water. We have totally forgotten about the water. We are overused, and we have abused water. Now, India is one of the water crisis country, one of the country which is facing water crisis. When we are facing, our Prime Minister had to go to Israel, study and come back, and now a lot of farmers, technocrats, construction work, many people have gone to Israel to study water efficient methods in that country, and they are trying to implement it here. So here's a small informative video, just go through it.
Is the world going into a water crisis? It certainly seems that way. The U.S. government predicts that by 2025, 60% of the world's landmass and 40 of our 50 U.S. states will experience water shortages, some of them extreme. The U.S. intelligence community sees worldwide water shortages as a major national security risk. Water scarcity helped trigger the Syrian civil war and has been a key reason why Africans have migrated in large numbers to Europe. More of this can be expected. But there is cause for optimism, and it comes from a very unlikely place, a country in the middle of a desert. That country is Israel. Compelled by necessity and powered by remarkable technological innovations, Israel has become the world's water superpower. By reusing wastewater, by making desalination affordable, by rethinking irrigation, and by developing an array of sophisticated water conservation techniques, Israel not only has a sufficiency of water, but an abundance of it. What Israel has done, other nations can do too, including its Mideast neighbors. And while it's a lot to hope for, cooperation on water issues could become the basis for cooperation on other issues as well. For Israel, an obsession with water is not new. The word water appears 600 times in the Hebrew Bible. For over 2,000 years, daily prayers for rain in the land of Israel have been a part of traditional Jewish ritual. For the founders of the modern state of Israel, water was not only a daily concern, but a paramount question of future survival. Vast quantities of water would be needed for the millions of immigrants who would make their way to the new country. Without plenty of water, economic growth would be impossible. But where was the water going to come from? It was a daunting challenge, but one which Israel overcame. Today, while other nations, even ones with far more natural water resources, struggle with water management, Israel has a surplus of usable would be needed for the millions of immigrants their way to the new country. Without plenty of water, economic growth would be impossible. But where was the water going to come from? It was a daunting challenge, but one which Israel overcame. Today, while other nations, even ones with far more natural water resources, struggle with water management, Israel has a surplus of usable water. The desert, as Israel's founders dreamed, is blooming. Not only does the country supply its own population with an array of fruits and vegetables, but it exports billions of dollars worth of produce to nations around the world. So how does a small country with little annual rainfall, with only one freshwater lake, and with no major rivers do this? It begins with a nothing wasted attitude that extends from the government to private industry to farming to consumers. Israel charges its citizens the market price for water, no subsidies. You can have as much water as you want, but you have to pay for it. And when you pay for something, you tend to be more careful with how you use it. This also extends to the nation's infrastructure. In virtually every country, massive amounts of water are wasted every year in leaky pipes. Israel has developed technology that tells it when and where a pipe is leaking so that it can be fixed immediately. This not only saves water, but it saves homeowners and industry money on their water bills. the biggest user of water in Israel and everywhere is agriculture. To get maximum use of its water, Israel developed the revolutionary farming technique known as drip irrigation, the process of applying micro amounts of water to individual plants at their roots. This is much more water efficient than the traditional method, still widely used around the world, of flood irrigation, flooding fields with water. Israeli scientists have also developed drought-resistant crops that need less water to grow. Sewage is usually thought of as a nuisance, but in Israel it is now a highly valuable resource. Israel takes nearly all of its sewage, treats it to an ultra-pure level, and then reuses it in agriculture. No other country utilizes sewage as comprehensively as does Israel. Israel has also pioneered the use of desalination, turning seawater into drinking water. Once it was thought to be prohibitively expensive. No longer. Israel built 5 giant desalination plants along its Mediterranean coast that together provide the equivalent of 80% of the water piped into Israeli homes. Putting all of these practices and techniques together, Israel has grown into a water superpower as well as a global center of water innovation. As the world grows drier and thirstier, those who want solutions will look to a little country in the middle of a desert for answers. Israel is ready with them. I'm Seth Siegel for Prager University.
So that was the effort they have made, not only in the collection of water, they have also taken all the measures. Nothing is free there. You pay for your consumption. Here in India, we have that problem. We give free everything. The more we give free, the more people waste it. We think the nature is giving us free and we waste it. That's the reason same thing is happening for the farmers also. Then government buildings also it's given free. Then guest houses, people waste it like that. So we need not get into those problems. Well, the case stories I'm not going to touch in this session. This I have just kept it as a reserve. Let's concentrate on this. Come what may. Come what may, let us do rainwater harvesting, preserving method in whatever place, wherever place we can. We need not bother. He will say something. He has not done. My engineer has not done. Neighbor is not done. This is not the point. We live in this nature. We take air. We take light. We use water. It is our duty to save and give and preserve it back to the nature. If that is done in each and every step of our day-to-day activity, whether it be construction or our domestic activities, we can all live happily in the days to come. So thank you very much. I'll be very happy if there are any questions to be answered, because 10 minutes at least I should give for questions, and hope I've done justice to the subject. Thank you. Over to the organizers.
All my participants will agree. So you are given an excellent information, a thought-provoking, and everybody has to carry some information to implement from their side. And your presentation is very, very good, sir. Even slides preparation and lot of the videos are self-educated, because you have shown a lot of picture. Our memory will carry, because that is a hats off to you, sir. And also you have done a great work and contribution during your service as a social service, I can say, and your district is become a model now. What I saw your presentations and your resume speaks. Hats off to you, sir. And also we wish to have one more lecture in the next online series. We want to show some of the case studies. And also I request any participants, if you have any queries, Sanath Kumar, you please take anybody is posted in chat box.
No,
You rightly mentioned, sir, you have attended, I am a life member of Indian Waterworks Association. Bangalore is not able to detect 40% leakage. So Bangalore is getting water from 300 kilometers. Very, very sorry to say. I am a fellow member of this. I attended a lot of conferences. Japan is only 3% leakage. Japan, major city, capital city, Tokyo. But Bangalore, 40% water unable to find where it is going. And also these are the high time, the administrators and all the leaders, they should take steps. And as it has to start from us actually as an individual. First, we have to educate ourselves and our family and surrounding people, ward-wise, area-wise. Then only things will move, sir. We cannot blame anybody. We cannot simply blame governments. because when we are not implementing at our home, so now you are a model to others, sir, because you implemented for your own house, your own office, the total rainwater harvesting system 20 years back almost. Very, very happy to see, sir. Congratulations for this. This message I'll request all Nirmithi Kendra engineers, whenever you are constructing a new projects, you add this proposal to the governments, convince them, because you are all working at district commissioner level. We can easily convince, just additional cost pipe networks. Definitely a lot of water we can harvest, save, and make use for mankind. Thank you very much, sir. Thank you a lot for your time and presentation. We wish to have a few more lectures, sir. I'm very, very happy on this. And also I request the participants to please interact with the speaker.
Parvatraj.
Yeah, Parvatraj. Please introduce you are from which Nirmithi Kendra.
Okay.
Then you can ask the question. If the video is not open, okay, audio is enough. If you are able to. Yeah.
Okay, sir. Sir, this seminar was very informative, sir, actually.
First introduce yourself, man.
Sir, ನನ್ನ ಹೆಸರು ಪರ್ವತರಾಜ್ ಅಂತ ಸರ್, ನಿರ್ಮಿತಿ ಕೇಂದ್ರ ಕಲಬುರಗಿಯಿಂದ. ಇದು ಈ ಸೆಮಿನಾರ್ ಬಹಳಷ್ಟು ಕಲಿಯೋದಿದೆ ಸರ್, ಮತ್ತೆ ಇಂಟರಾಕ್ಷನ್ ಇನ್ನೂ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ಬೇಕಂದ್ರೆ ನೀವು ಒಂದು ಆಫ್ಲೈನ್ ಕ್ಲಾಸ್ ತಗೋಬೇಕು ಸರ್ ಮೋಸ್ಟ್ಲಿ.
Yes, sir. No, sir has created a history in his place. He is actually the executive director of the Nirmithi Kendra. Sir, therefore, you just take this as a one role model is there with your department itself. Why you cannot just implement? What, sir? Just make a cut and paste with a small level. Whenever there is a big problem, definitely sir is available to come for rescue and give solutions technically.
Okay.
Yeah.
Sir, one question sir ನಂದು. ಮತ್ತೆ ಇವಾಗ ಪರ್ಕುಲೇಷನ್ ಫಿಟ್ ಮಾಡುವಾಗ ಸರ್ ಏನನ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು, ಕೀ ಪಾಯಿಂಟ್ಸ್ ಫಸ್ಟ್ ಆಫ್
ನಾನು
ಡೈರೆಕ್ಷನ್ ಲೊಕೇಶನ್
ಇಲ್ಲ ಡೈರೆಕ್ಷನ್ ಲೊಕೇಶನ್ ಪ್ರಾಬ್ಲಮ್. ನೀರೆಲ್ಲಿ ಹರಿತದೆ ಅದ ನೀರು ಹರಿಯುವಾಗ ಪರ್ಕೊಲೇಷನ್ ಪಿಟ್ಟಿಗೆ ಬಿಡಬೇಕಾಗಿದ್ದು ನ್ಯಾಯ. ಆದ್ರೆ ಒಂದು ನೀವು ಬ್ಲಾಕ್ ಕಾಟನ್ ಸಾಯಿಲ್ ಇದ್ರೆ ಪರ್ಕೊಲೇಷನ್ ಪಿಟ್ ಅಷ್ಟೊಂದು ಹೆಲ್ಪ್ ಆಗಲ್ಲ. ನೀವು ಸ್ವಲ್ಪ ಹುಷಾರಾಗಿರ್ಬೇಕು.
ಅದೇ ಸಾಯಿಲ್ ಟೈಪ್ ಮೇಲೆ ಡಿಸೈಡ್ ಆಗುತ್ತೆ.
ಸಾಯಿಲ್ ಟೈಪ್ ಮೇಲೆ, ಸಾಯಿಲ್ ಪೋರಸ್ ಆಗಿದ್ರೆ ಅಥವಾ ನೀರು ಎಳ್ಕೊಳ್ತಿದ್ರೆ ಮಾತ್ರ ಪರ್ಕೊಲೇಷನ್ ಪಿಟ್ ವರ್ಕ್ ಆಗುತ್ತೆ. ಎಲ್ಲವೂ ನಾನು ಹೇಳಕ್ಕಾಗಲ್ಲ. ನಾನು ಹೇಳಿದ್ರೆ ಬೆಳಿಗ್ಗೆ ಸಂಜೆವರೆಗೆ ಮಾತಾಡ್ಬೇಕಾಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನೀವು ಇಲ್ಲ, ನೀರ್ ಎಲ್ಲಿ ಹರಿತದೆ ಅದನ್ನ ಡೈವರ್ಟ್ ಮಾಡಿ ಆ ಪರ್ಕೊಲೇಷನ್ ಪಿಟ್ಟಿಗೆ ಬಿಡೋದು. ಆದ್ರೆ ನಿಮ್ ಕೊಸರು ಕೊಳಚೆ ಅದನ್ನೆಲ್ಲ ಪರ್ಕೊಲೇಷನ್ ಪಿಟ್ ಬಿಡ್ಬೇಡಿ. ಅದು ಬಿಟ್ರೆ ಅದೇ ತುಂಬೋಗುತ್ತೆ. ಅಷ್ಟಕ್ಕೆ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಕೊಳಚೆ ಮತ್ತೆ ನಿಮ್ಮ ಮಡ್ಡು ಅಥವಾ ನೀರು ಕಸ ಕಟ್ಟಿ ಪರ್ಕೊಲೇಷನ್ ಪಿಟ್ ಒಳಗೆ ಹೋಗದಾಗೆ ಅದ್ರ ಮೊದಲು ಒಂದು ಜಾಲಿನೋ ಗ್ರಿಲ್ಲೋ ಏನಾರು ಇಟ್ಬಿಟ್ಟು ಒಂದು ಸ್ವಲ್ಪ ಆರ್ಡಿನರಿ ಮಿಕ್ಸ್ಡ್ ವಾಟರ್ ನೆಲದಲ್ಲಿ ಹರಿಯುವ ನೀರು, ನಿಮ್ಮ ಇಂಟರ್ಲಾಕ್ ಮೇಲೆ ಅಥವಾ ಕಾಂಕ್ರೀಟ್ ನೆಲದ ಮೇಲೆ ಹರಿದ ನೀರು, ರೋಡ್ ಮೇಲೆ ಹರಿದ ನೀರನ್ನ ಪರ್ಕೊಲೇಷನ್ ಬಿಟ್ಬಿಡಿ, ಏನೂ ಆಗಲ್ಲ.
ಇನ್ನೊಂದು ಕ್ವಶನ್, ಜೀರೋ ಮೇಂಟೆನೆನ್ಸ್ ಬಿಲ್ಡಿಂಗ್ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್, ಕೆಲವೊಂದು ಟೆಕ್ನಿಕಲ್ಸ್ ನೀವು ಆಲ್ರೆಡಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡ್ತಿರ್ಬೋದು ಸರ್ ಮೋಸ್ಟ್ಲಿ ನಿರ್ಮಿತಿ ಕೇಂದ್ರದಲ್ಲಿ. ಅದ್ರದ್ದು ಏನಾದ್ರು ಬ್ರೀಫ್ ನೋಟ್ಸ್ ನಮ್ಗೆ ಏನಾದ್ರು ಕೊಡ್ಬೋದಾ ಸರ್? ಅಂದ್ರೆ ನ್ಯಾಚುರಲ್ ಆಗಿ ಮೋಸ್ಟ್ ಕಾಮನ್ ಯೂಸ್ ಮಾಡೋದು.
ಆಯ್ತು, ನಾನು ಫೋನ್ ಮಾಡಿ ಮೇಲ್ ಮಾಡಿ ಕೊಡ್ತೀನಿ.
Parvatraj, why you cannot visit sir center?
ಅದೇ ವಿಸಿಟ್ ಮಾಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ.
It is in India only, not in abroad. So you will just find a free time. If possible, we all go together and see the lot of work he has contributed. I'm happy that sir has used a lorry backer concept, because few projects we have worked in Coimbatore, Kerala, sir, there is no plaster at all outside.
I know.
Because he is a pioneer in construction of all mud blocks. Even I visited the Pondicherry, where the ferrocement roof paneling, the parabolic shape, they built 2 floors.
Yeah.
There is only parabolic ferrocement paneling. I am also a member of the ferrocement association, sir. It is there in Pune. But lot of works are going in Mata Institute in Pondicherry. Technology is available. Now everybody has to sit with an open mind, convince our leaders, our authorities, and try to improve. That is only my suggestion for all Nirmithi Kendra engineers. See, we have a technology information. You must browse all this information. Sir has shown a lot of YouTube lectures. See, just go to that. All the solutions will get. Somebody asked percolation. He is having a YouTube. See, those YouTubes you have to browse yourself. You have to educate yourself. Try to implement at your level. This is only my suggestion, request to all the participants. And now, any other questions?
The director, sir, is there?
Sir, good evening, sir.
Sir, good evening.
Sir, please, sir.
Good evening, Rajendra.
Ah.
Wonderful, sir.
Srinivas Rao ಹೇಳಿ. Thank you,
Yes.
thank you.
So all participants enjoyed. So
Very
it is one of the
interesting
model center in state, sir. Actually,
That,
Professor,
sir,
sir.
I
Dakshina is
observed,
one
I
of the
saw
model center.
all the even office means I understood that it is he has spread tentacles away from Mangalore also, sir.
Yes,
Lot
yes.
of work, sir.
Yeah.
Definitely, we must visit, sir. Once we'll find a time and we'll go and see, sir.
Yes.
Yes,
You
sir.
should plan for.
We'll have one day workshop there itself, sir.
Yeah.
Yes,
Please
sir.
come.
Yes, sir. Sanat Kumar,
Excellent.
you have
Thank you, Rajendra. Thank you for
Thank you.
being with us today.
Thank you, Srinivas. Thank you.
Yeah,
Thank you very much.
Any other questions from the participants? Namrata? Pavitra? Arpita? There are a lot of participants are there. We can understand only two things. I need not elaborate. They know everything, sir.
Professor, sir, first century in state involved in the private housing program.
Okay, sir.
Private housing program.
Uh-huh.
And he has covered both the cost-effective technologies and rainwater harvesting.
Yes, sir.
It's good that so our young engineers, they should learn all these things.
Yes, sir. We have to take it first VTU campus also, sir, Muddenahalli.
Yes.
Because I am staying in the quarters only. I know the scarcity of water and the availability of water. We should implement, sir. Definitely, we can submit proposal to our vice chancellor. Also, one proposal, sir. Because we are sharing the premises, at least we can give.
Yeah, they are facing proper water issue. The water problem issue is there.
Yes, sir.
So if they adopt rainwater harvesting system in their campus,
yes, sir.
I think
they can solve the issue, sir.
Yeah, they
Yes,
can
sir.
solve the issue.
Yes, sir. Yeah. Any other questions, Sanat Kumar?
Feedback link is shared, sir.
Yeah. So all the participants, I'll request to give your feedback. It will be useful to us to conduct similar programs with the good speakers and all these inputs, and also attendance and certification purpose. Those are from other colleges also. Thank you, Rajendra sir, once again.
Thank you, sir.
Enjoyed your lecture. I don't know how the 2 hours has gone. Definitely, we wish to have one more lecture in the 4th phase, sir, online. If permit, if you have free time, we will invite you in the 3rd phase itself, sir.
Thank you very much, sir.
Thank you.
Thank you very much.
Thank you very much, sir. Thank you.
I can leave?
Yes, sir. I request all the participants give your feedback and please